Hello students. Today we are going to study 10th science chapter number 1 gravitation. So here this is lecture number 1. So in this chapter we have to see only particularly the points. The main points in this chapter are gravitation, then circular motion and centripetal force, then Keplers laws, Newton's universal law of gravitation, acceleration due to gravitational force of earth, then free fall, and last topic is escape velocity. So thus these are the main points in this chapter we have to study. So we are going to study these points in details. First point now is the gravitation. Now in ninth standard we are familiar with this term, that is gravitational or gravitation. So this gravitation was discovered by the scientist, that is Sir Isaac Newton. So here we have to study this first point, that is gravitation. So see, as we learn, the phenomenon of gravitation was discovered by Sir Isaac Newton. As the story goes, he discovered the force by seeing an apple fall from a tree on the ground. He wondered why all apples fall vertically downward and not at an angle to the vertical. Why do they not fly off in a horizontal direction? So Newton observed that the apples are falling from the apple tree in the downward direction on the earth's surface. Now he thinks that why these apples are not falling in a horizontal direction, or why they not fly off in the horizontal or any direction. Then after much thought, he came to the conclusion that the earth must be attracting apple towards itself, and this attractive force must be directed towards the center of earth. The direction from the apple on the tree to the center of the earth is vertical direction at the position of apple, and thus apple falls vertically down. Then after much thinking, he got the conclusion, that is, if apple falls in the downward direction, because the earth will be attracting the apple. Due to attraction force of earth, these apples are falling in the vertically downward direction, and that force of attraction is towards the center of earth, and it is vertically downward. So see here, figure is given. So in figure we can see there is an apple tree. Newton is sitting under the apple tree and he is observing the falling apples. Okay, so figure 1.1 on left shows an apple tree on the earth. The force on an apple on the tree is towards the center of earth. So that force of attraction is towards the center of earth, that is along the perpendicular from the position of apple to the surface of earth. The figure also shows the gravitational force between the earth and moon. The distances in the figure are not according to scale. So you can see in figure another two things, that is earth and moon. So there is attraction force between earth and moon also. So that attraction force is again directed towards the center of earth. So Newton thought that if the force of gravitation acts on apple on the tree at the different height from the surface of the earth, can it also act on object at even greater heights much further away from the earth, like for example the moon? Can it act on even further objects like the other planets and the sun? So Newton thought that if earth attracts the apple from the apple tree, so if can it also act on the object which are further away from the earth? For example, suppose there is a moon, there are stars in the sky, there are different planets also. So can that gravitational force attract these objects also which are far away from the earth? Okay. Then next point is the free force and motion. So we have seen that force is necessary to change the speed as well as direction of motion on the object. So here we have to study the circular motion and centripetal force. Second point. So here in first point we study about the gravitation. Gravitation was discovered by the scientist Isaac Newton, and according to Newton, the earth attract the objects that present on the earth's surface or on the higher height from the earth's surface. Uh, Also, earth attract the object from the higher height like moon and then other planets also. So this is attraction force due to which the object fall on the earth's surface. Then next is the circular motion and centripetal force. So before that, the introduction to scientist is given, that is about Sir Isaac Newton. So read that introduction. Uh, we'll see the next point, circular motion and centripetal force. So we can see in the diagram what is circular motion and centripetal force. So the boy is standing with in his hand a string is there, and that string is tied with a stone, and he is rotating that string. So that rotating motion is the circular motion, and that string applies the force on the stone, and that force is directed towards the center, and therefore it is called as the centripetal force of attraction or centripetal force. So see, tie a stone to the one end of string, take the other end in your hand and rotate the string so that stone moves along a circle as shown in the figure. Are you applying any force on the stone? In which direction is this force acting? How will you stop this force from acting? What will be the effect on stone? So we can see here, stone is rotating in a circular path, and this is due to the force that applied through the string. So as long as we are holding the string, we are pulling the stone towards us, that is towards the center of circle, and are applying force towards it. So as we join the string to the stone, that string applies the force on the stone towards the center of circle. In this case, the stone will fly, the force stops acting if we release the string. So if we release the string, that force will stop, and that stone will fly off along a straight line which is tangent to the that circular path. Okay, then you may recall that we have performed similar activity previously in which a 5 rupee coin kept on rotating circular disc. Then see, thus the force act on any object moving along circle and it is directed towards center of circle. This is called centripetal force. So definition for centripetal force is given, that is a force acts on any object moving along a circle and it is directed towards the center of circle. This type of force is called centripetal force. Centripetal means center seeking, that is, the object tries to go towards the center of circle because of this force. So, centripetal force is those force which is acting on a object which is moving along a circle and the direction is towards the center of circle, and centripetal means the center seeking, therefore object tries to go to the center or towards the center. You know that moon, which is a natural satellite of earth, goes around in the definite orbit. The direction of motion of moon as well as its speed constantly changes during this motion. Do you think some force is constantly acting on moon? What must be the direction of this force? How would its motion have been if no such force acted on it? Do the other planets in solar system revolve around the sun in a similar fashion? Is similar force acting on them? What must be the direction? So we know the moon is also rotating around this earth by the same manner as we see above example. So there is centripetal force acting on the moon and that centripetal force holds the moon and the moon rotates along the around the earth by due to the centripetal force. And if there is no such force, then same as the case of stone, if no force is applying on stone, then stone will fly off in a tangential direction. Similarly, if no force between earth and moon, the moon also fly off in a tangential direction. From the above activity, example and questions, it is clear that the moon to go around the earth, there must be a force which is exerted on moon and this force must be exerted by the earth which attracts moon towards itself. Similarly, the sun must be attracting the planets including earth towards itself. So, as there is attraction force, that is centripetal force is between earth and moon, the another planets and sun is there. So sun is at the center and the planets revolving around the sun are due to centripetal force, like sun and earth revolve around the sun and this is due to the centripetal force. Okay, so this is about circular motion and centripetal force. So what is definition for centripetal force? Centripetal force, so centripetal force is the force which act on any object moving along a circle and it is directed towards the center of circle. So this force is called centripetal force. Example of centripetal force: if we tie a stone with a string and rotating, then it is example of centripetal force. Another examples: the moon revolving around the earth due to centripetal force between Earth and Moon. Another planets which rotate around the Sun, and this is also due to the centripetal force between Sun and that planets. Okay. Then next important point is now the Kepler's law. So before the Newton, the scientist Johannes Kepler gives some important laws or three important laws, and based on these three important laws, the Newton gives his law of gravitation. So here we have to see the Kepler's law. So, planetary motion had been observed by astronomers since ancient times. Before Galileo, all observations of planets' positions were made with naked eyes. By the 16th century, a lot of data were available about planetary positions and motion. Johannes Kepler studied this data. He noticed that motion of planet follows certain laws. He stated three laws describing planetary motion. This is known as Kepler's law, which are given below. So Kepler studied about the position and motions of the different planets in the sky, and he gave three important laws, and that laws known as the Kepler's laws we have to discuss here. So before starting the Kepler's law, here we should know about the concept of ellipse. Okay, so we should know the concept of ellipse before starting the Kepler's law. So see, an ellipse is the curve obtained when a cone is cut by an inclined plane. It has two focal points. The sum of the distances to the two focal points from every point on the curve is constant. So, if a conical plane or cone is cut by inclined plane, we can see in this diagram. So cone is there, and that cone is cut by the inclined plane. So that circular part after cutting is the ellipse. So ellipse is not a completely circle, it is slightly different from the circle. So that part is called as the ellipse. So as we can see in the diagram also, when cone is cut by inclined plane, then that cut is the shape of ellipse. Then we can see F1 and F2 are two focal points of ellipse shown in the figure. If A, B and C are 3 points on the ellipse, then see here A1, sorry, AF1, that is this distance, AF1 plus AF2 is equal to BF1 plus BF2, and also it is equal to CF1 plus CF2. Okay, so this is concept of ellipse having two focal points, and it is the cut by inclined plane to the cone. Then the Kepler's law. Now the Kepler's first law, the orbit of planet is an ellipse with the sun at one of the foci. So this is first law of Kepler. The orbit of an planet is an ellipse with the sun at one of the foci. So every planet revolves around the sun in the orbit, and that orbit shape is ellipse shape as we see in above the ellipse. Okay, so we can see in the diagram also ellipse shape. So it is not completely circle, it is slightly different from circle. We can consider example for ellipse as a egg. So shape of egg is also ellipse shape. So such shape, in such shape planets revolve around the sun. Okay, in the ellipse shape. So this is simple first law, statement of first law, that is the orbit of planet is an ellipse with the sun at one of the foci. So you can see in the diagram sun is at the center and the planet, suppose planet A is there and that planet is revolving around the sun in the ellipse shape. Okay, so this is simple first law of Kepler. Then Kepler's second law. Now Kepler's second law is there. The line joining the planet and sun sweeps equal areas in equal intervals of time. Okay, now see, this is the statement and see what is statement for this second law. The line joining the planet and the sun sweeps equal areas. Suppose initially planet is at the position A and in certain time or in time certain time interval this position of planet changes from A to B. Okay, and here is the position of sun and A changes its position from A to B in certain time. Suppose that certain time maybe we can take as a x minute. So in x minute the A planet A travels from A to B in how much time? That is x minute. Now in same time if that planet is at the position C, planet is initially at the position C and time is same, that is x, then in time x this planet C moves from C to the D. So this movement is from C to D. Then similarly if planet is at position E and in time x it moves from E to F. Okay, in time x it moves from E to X. So here we can say time is same. Here time is x minutes, here is also x minutes and here is also x minutes. Now in this interval of time, that is x minute, the area covered by the planet with the sun is same, that is this dark portion, dark blue color portion is the area which covered by the planet. So this area is same at each time. Okay, area is same. This area, that is ASB, this is equal to area CSD and it is equal to ESF. So all these three areas are equal in the same interval of time. So this is second law of Kepler's. So the line joining the planet and the sun sweeps equal areas in equal interval of time. If time is same, then their area is also same. Then the third law of Kepler. So statement is the square of its period of revolution around the sun is directly proportional to the cube of the mean distance of planet from the sun. Now square of period of revolution. So what is mean by period of revolution? Period is nothing but the time required to rotate around the sun in one complete rotation, for time required for one complete rotation, that is called the period. So that time period, square of this period of revolution is directly proportional to the mean distance from the sun. Okay, so that time period of revolution is indicated by t, and square of this period of revolution is directly proportional to cube of distance. So cube of distance, that is distance between sun and planet, is taken as r and its cube. So t square is directly proportional to r cube, and we can simplify this. So this t square is equal to, we can write this directly proportional, we can cancel this directly proportional, and we can take here constant. So t square is equal to constant into r cube, and therefore we can write here final step, here t square, we can write here t square upon r cube. This r cube become divide to this side, so t square upon r cube is equal to, here constant, we can write constant as a k. Okay, so this is third law of Kepler. What is third law? The period of square of period of revolution is directly proportional to the cube of mean distance of planet from the sun. Okay, so thus we studied here three laws, three Kepler laws. So first law, Kepler's first law is about the uh, orbit of planet is an ellipse with the sun at one of the foci. So that orbit of rotation around the sun is in the shape, that is ellipse shape. Okay, not in the circular shape. This is simple first law. The orbit of planet is an ellipse with the sun at one of the foci. Then second law is the line joining planet and the sun sweeps equal areas in equal interval of time. So in equal interval of time, the area covered by the planet is equal. And third law is the square of period of revolution around the sun is directly proportional to the cube of mean distance of planet from the sun. That is, the period is nothing but, or we can write in symbol, that is t. So t square is directly proportional to r cube. Okay, so these are three Kepler laws. So there will be question, state Kepler's law. So state Kepler's first law, or state Kepler's second law, state Kepler's third law, like this. So we have to remember these statements for three laws. Okay, so here we see till Kepler's law. So we'll stop here. We'll study the next topic in the next lecture.